Good morning, Louisiana, and everybody out there from BNet TV land. I know that my team loves it when I say that. Welcome to day 3 and the wrap-up for CTIA. I have a wonderful esteemed panel this morning, but from Mr. Stephen King from 3M, Mr. Omar Flores from 3M, I have Mark Rice from Altair Communications, and Mr. Warren Demansky from Newfield Wireless. How are you today, gentlemen?
Doing great. Doing great.
Fantastic. Great city, great conference. Absolutely wonderful. CTIA always puts on a great show, but who can beat New Orleans for a show?
Yeah, absolutely.
Everybody's had some good food, some good oysters, and seen some good jazz. As everybody out there can hear, I have very little of a voice left, but that's okay. Viewers out there, if you want to email in your questions to ctia@bnettv.com and or tweet them to @bnettv, please feel free, and we will try to get to those as soon as possible. Gentlemen, for our viewers, please introduce yourselves and what your portion of the ecosystem is.
Thanks, Tony. I'm Steve King. I'm an applications engineer with 3M, and we're involved in the infrastructure, backhaul, the tower, small cells, and DAS.
Good morning, Johnny. My name is Omar Flores. I work for 3M. I'm a business and marketing manager for 3M with focus in wireless infrastructure for the tower. And we're mainly focused in bringing solutions for fiber to the antenna, together with weatherproofing and fiber connectivity.
Morning, Tony. Warren Demansky, Newfield Wireless. We make a product called TrueCall that locates and LTE calls in real time on wireless networks.
I'm Mark Rice, VP and GM of Americas for Altair Semiconductor, and we are a fabless semiconductor manufacturer that makes LTE chips for end user devices.
So you guys are the panel that I think people have been most excited about, because you are really the entire back end of the system that makes all this good stuff work. I've spoken to a lot of companies about applications, about payments, about front-end things that the consumers like to play with, but the most important stuff is how the data flows on the back end, and what type of chips we're using, what type of tower infrastructure we're using, and how to get that data from one area to the other. Why don't we start off by talking about some of the trends that we've seen here at CTIA, what's hot and what's not?
So absolutely, I think that a big part of the drive for the infrastructure side is FTTA, or fiber to the antenna. So what we're seeing right now is a paradigm shift away from the hardline coaxial based systems to ones where you run some number of fibers and power cables up to a remote radio unit, and then you have a small coaxial jumper going to the antenna. This is being driven by the needs of LTE and high capacity data systems to support all our tablets and smartphones in these high mobility applications. And in these sort of scenarios, we see very high density, for instance, at the base of the antenna remote radio unit. And in conjunction with that, we've just announced on Tuesday the launch of our Slim Lock closure, specifically to meet the demands and needs of that specific area of the environment at the top of the tower.
So we're basically bringing solutions to make this migration from coax to fiber in a very easy way. One of the main concerns is how can you make connections in the same way where coax was made. I mean, mainly in the field, easy, and we're bringing solutions. We have a specific solution that is called NPC, which is non-polished connector. This connector makes the connection very easy and fast in the field, in the environment where you want to make that connection in the tower.
So Tony, our booth has been busy. It's been a very fun show. New Orleans, what can I tell you?
Well, it's New Orleans, right?
Yeah,
so
it's got to be fun.
And as Steve has pointed out, he's the booth babe of his booth.
Yeah, right. And I'm not.
The only one that makes you the booth babe of your booth.
Clearly I'm not. But I'll tell you, LTE's been live on the air for about a year and a half, roughly. And what's really interesting about LTE is the variability in the customer experience, even in the same network. So as you move around as an LTE subscriber, you'll see wide variation in the experience you have in terms of throughput and things like that. And our customers and the people that are visiting our booth are really interested to know why that's happening. They're very interested to know where there's a lot of demand for the LTE network and where they should be placing small cells. And if you come to our stand, I can show you live geolocated LTE calls, and we can explain exactly how and where and why an operator should place a small cell to help offload that capacity.
Okay, and at the opposite end of the ecosystem with the devices, we need to enable people to deliver the services into the hands of consumers, and not only In typical consumer devices, there's a lot of buzz and excitement around poor smartphones that we all relate to. But there's a lot of concern of now how do we migrate as AT&T migrates from their 2G spectrum over to LTE, and Verizon goes straight forward to LTE. What happens to all the MDM markets, and how do we exploit that? And what do these people do that need a 5 to 7 year lifespan and very competitive cost?
So,
and then furthermore, to some of these issues with field deployments, a lot of issues come up that really aren't anticipated. Need a lot of flexibility, different algorithms to cope with different conditions that we are finding as we're ramping in different deployments. So what we're doing in our contribution there is we have a software configurable, software-defined radio, and we're able to change the product, modify the product as different conditions come up for the customers, and also very cost-effective, so we can address this changeover from 2G to 4G in these M2M spaces.
You know, Mark, you bring up a really good point about the M2M stuff, and I'm glad that we're going to touch on that. When it comes to the handset, we all fairly know that the consumer is going to pass that phone on in approximately 2 years, right?
Yeah.
To 3 years. But the life cycle of it, okay, is maybe going to push the higher end of 3, tops 4, not so much in the M2M market, right? If you put a chip into a refrigerator, for argument's sake, or a piece of field equipment, you're not changing that out in 3-4 years. Right? But you're going to have to deal with some spectrum issues. We're going to have to deal with the changing infrastructure. What are some of the challenges involved in what we're seeing come forward in the M2M market to help build up through or ramp up to the, what did the GSMA came out with the report and said there's going to be 14 billion connected devices by the end of 2021 or something like that?
Yeah, yeah. And it's also important to understand how those devices are interacting with the network.
Right.
Right? So you have this broad ecosystem from, as you say, fridges, right, to 4G devices, and how they work with the network and understanding individual device performance is a very important aspect of what we do as well. So it's kind of critical to understand what happens in your network when you introduce devices, new devices for that matter.
Warren, you know, when you and I had a chance to speak in Barcelona, you had a wonderful demo going on there. Where, we got to see some good heat sinking of areas that were going to be congested or less congested, where the network was able to view where to put particular antennas or different infrastructures, which was fantastic. Again, what are some of the challenges that you're seeing now? You know, where you've deployed that product. There's issues. Yeah,
let's talk about that. It's really interesting. As I mentioned, I'm an LTE subscriber. I pay for an LTE 4G experience. What's really interesting to me, and you see it on these heat maps that we generate, you see this wide variation in throughput as you move around the network. And an understanding of why that's occurring and how to fix that is really, really important. The other thing that we see, surprisingly, is the amount of time that 4G subscribers are actually operating in a 3G world. In other words, they've got a 4G device, but because of CS fallback and technologies like that, they don't really operate at a 4G level. And an understanding of that is very important for operators today that are rolling out LTE networks.
Okay, so my phone, I have an iPhone 4.5. I have it says 4G at the top of it.
Yeah, right.
Right? Okay, sure. There is no way that I am getting a 4G throughput. I'm not even getting an HSDPA plus throughput. And I know that because when I have to download something, and something that's not even big, maybe it's my email, which could be, let's say, 4 to 5 meg, it's taking too long.
Right. So it's really important to understand why that's happening. So I do have an LTE phone, and I've been doing my own personal testing as I move around the city. Yesterday here, roughly, I was getting 35 megabits per second down, roughly, but I can tell you I was getting as low as 2 or 3.
Right, and so the peaks and valleys, the spikes that are coming up, it's like 1 second you're like, holy cow, look that, and then you're like, oh, I just went to go download my email, and
and
I'm going to go for coffee.
So we help you understand where in the network that happens and why it happens. And we help operators know how to fix that so that their customers really do get a 4G experience.
Stephen, Omar, I want you guys to jump in here. I mean, we're looking at some of the infrastructure that you're deploying. How are we going to fix a lot of this?
Well, see, this comes into exactly Warren's point. So one of the things with LTE services, the LTE provider will try and hang on to your LTE signal as long as possible. So ultimately, with distance effects and interference, your signal noise eventually gets to the point where it becomes untenable. It has to do a soft handoff to a 3G network, right?
Okay.
So that's kind of, you see that flip-flop back and forth. But the end result is the carriers have to deploy sometimes 3-4 radios per sector now.
Okay.
And that's a big density concern, right?
Okay.
So in support of that, they have these multi-band, multi-service antennas, and they have like somewhere between 4 and 8 RF ports on the base, and they're very closely packed together. So it's very difficult and problematic to, say, tape wrap these for weatherproofing.
Okay.
I mean, try and imagine these things are 0.6 inches away from each other, and you're trying to get even a wrench around them, much less, you know, a tape roll.
Okay.
So in support of that, we developed this slim lock closure. So this comes to the point of how do we try and enable quicker and more reliable installations. So say this is the base of an antenna, just one port. The technician or tower hand can come up and with one hand, he can close this around it. And then basically he can park this one, slide it up into place, and have an IP68 ready connection for weatherproofing. It's also removable, and if he needs to take it off at a later date to, say, do PIM testing on this antenna connection, it comes right off. So you could have 20 minutes for tape wrap or 20 seconds for this closure.
So the service time gets cut down immensely if there's an issue with the antenna.
And the installation time.
And the installation.
Because remember, there's 8 of these ports at the base of the antenna, and there's a corresponding 8 ports on the radio heads. So if each one of those is 20 minutes, you can do the math, and you can see where 20 seconds per weatherproofing connection is huge.
Is weatherproofing a huge issue for throughput?
It is a huge issue. One of the main issues that most of the carriers have is PIM, is passive intermodulance issues. So most of the times water is intruding into the cable, and that leads you to service outages. 3M is a company focused on protecting and connecting, and we know how to do that. And most of our new technologies, like the slim block or fiber connectivity, were designed to do it in a fast way and easy way. So all our technologies are based in bring speed to this new construction. That's how basically our.
Let's look at the global market. I mean, we spent a lot of this conference obviously concentrates a lot within North American borders, but I know that everybody was at MWC. What was your perspective from the 2 different continents? How are each one of them operating? Is one doing better than another?
Can I take a stab at it?
Mark's like, I've got a lot to say about this.
Well, you know, from an LTE perspective, I think that the European community is really looking to America and North America as a leader in LTE, because we've had LTE deployed here longer than most every other places, with the exception of Japan and Scandinavia. And so, the largest operators that went LTE first are here. And so all the lessons learned, all the learning in the last year and a half largely has been done here. So when I'm talking with operators here about problems in LTE, they understand and they relate. They're already living those issues. When I do the same thing with operators in Europe, to a certain extent, there's a learning going on because they haven't really gone there yet. So let me give you an example. Voice phones on LTE in Europe were only introduced this year, right? Phones that prior to this year, they were using data dongles only, right? And if you look at the LTE networks here, they were launched right out of the gate with voice phones. And so operators here had to learn how to deal with CS fallback and EHRPD right from the get-go. It's a relatively new phenomenon elsewhere. So it's kind of nice to be leading the market again in wireless. I mean, from the LTE perspective, that's certainly what I think is happening.
Do you think that we lacked of it here in North America for quite a long time, and now it's great to see us being a leader again?
In my opinion, we were behind on 3G,
okay,
and I think we're ahead on 4G.
In my experience, the transition from 2G to 3G in Asia was way faster and earlier. The transition from 3G to 4G in America is really going ahead of any other region in the world.
Mark, I want you to chime in on this.
Yeah, I just had a flashback. That's why I was grinning like that to a researcher at one of the big Korean operators two years ago, and he decided that I can picture his face with the sadness washed over his face, and he said, you know, this will be the first time where we won't be able to lead.
Wow.
Because
wow, that's powerful.
Because we haven't paid for the 3G network yet, and we will have to follow with LTE.
Wow.
And as a as an advanced technologist, it just made him
sad.
Right?
It was sad.
You know, he wanted to be on the bleeding edge.
Right, especially when you're used to being on the bleeding edge.
Yeah.
And you know,
and we are on the bleeding edge, and you know, a lot of the things that you've talked about with the network and what we see when we go into deployments is that LTE specification is a toolkit, really, and the operators have different types of problems that they're solving, right? If you're in a high density situation where your antennas are close together, you've got a different type of issues that you're solving with the air link. You know, and we've had to develop software where we can look out from the device at that air link and see what's going on, as well as when you're looking at the network to see what's going on. Because these problems are there and they're evolving, and when you squeeze one thing here, something else gives.
So it's a water balloon.
Yeah, and sometimes it is, and you've got to get the right kind of optimization.
Okay.
So when when O2 is trying to optimize in a rural area of Germany, it's in a low frequency. It's different than when SoftBank is trying to optimize with antennas 100 meters apart in downtown Tokyo. Right. I mean, it's in a 2 gigahertz spectrum.
Ouch.
Right. It's a completely different type of thing. And now when we put the TD and the FD together in the same device like we do, and we hand over between the two, which we have demonstrated, then it really gets tricky. You know, and low frequencies and high frequencies. And what are those optimizations, and how do we get the right the right algorithms, and the operator? What choices does he make to have the network operate correctly?
If I could give a plug for the Koreans, I was just there.
Okay.
And all 3 national operators now are running with LTE.
Okay.
Oh, yeah, they're playing
They're all running with LTE. The devices they have there are, I'm not sure if they're phones or laptops or both. I mean, they're gigantic laptop devices, and so. Yeah, you're right. The Koreans are not used to playing catch up, or the Japanese for that matter. And I went from there to Japan. There's 2 national operators running LTE there. And I still stand, what I mentioned about the lessons learned here are just now being learned there. I think there's going to be something like 168 live LTE networks on air by the end of this year.
Okay.
Right? That's almost 2 orders of magnitude from where it was a year and a half ago.
Okay.
Right? And so all the things that are going on in the 4G network are really interesting to see. A, how people use the phone. B, what the real experience is as the network loads. What applications they use, those kinds of things are very interesting to understand. And it's still early days. I mean, we still are learning about all these things in real time.
and to echo Warren's point, if you think about Korea and think about North America, specifically United States, they're fiber-rich countries.
Right.
So Korea made the conscious decision to go to fiber infrastructure years ago, and with the U.S., with the MSOs and the cable back end for all the television services, so that made it possible to quickly get fiber for the backhaul to these cell sites and all the locations, and that's sort of an advantage because you're stepping it up from, say, requiring 10 megabits per second for a 3G cell site, not non-HSPA, standard voice 3G, to needing 300 to 500 megabits, right? And even that's not enough, because what you're starting to see now is this big stress on the backbone network from particularly Netflix. 60% of the backbone content.
Sandvine had a fantastic report out about the over-the-top. I know everybody was was reading that about the over-the-top players and where the consumption was coming from. And you're right, it is very stressful for the backhaul. And so, do we have enough dark fiber do we have enough offload infrastructure that's not being utilized that we are going to start to increase capacity of?
In a word, no, and that's why
no.
There's builds going on, and I think they're desperately trying to anticipate what that tipping point is. But the big danger is going to be that the advances in the smartphones and tablets and the ability to stream data, because if you look at the compression algorithms that are coming out, where you can gear the video stream to your tablet if it's tablet sized, or to your phone if it's phone sized, or they know what the end screen is, and you squash the content accordingly, right? And so even with all those advances, still the take rate is through the roof. And so what you start seeing is the need to deploy more elegant ways to get more out of the fibers. So let's say you ran a few fibers out, but you don't have any dark fibers left, and it's, you know, some cornfield somewhere.
Right.
And so what do? Well, you start looking
Jump
at
on the cable,
WDM.
Absolutely.
You know, you have to be creative with these things.
Okay, so is that one of the reasons why North America was able to jump ahead at such a quick rate, is because we had this existing infrastructure that wasn't really being utilized, whereas other countries probably had already utilized that?
Well, I had somebody ask me about an operator in a third world and saying, well, how, you know, how will we know if they're going to be able to deploy, you know, 6 months from now? And I said, well, you would have seen them trenching 4 years ago.
Right. Yeah. Right.
And I think so. You know, to a great extent, Verizon's position is due to their FiOS push. They looked a little bit wacky, and they really got hammered financially.
They got hammered financially for that, and I was consistently defending them and saying, "You people are nuts!
Yeah.
You're nuts! What do you? Of course, it's a good move." And everybody who has FiOS today is like, "I got FiOS."
But it was
absolutely, you know it.
Carry that, and that's what's carrying the LTE.
Right, absolutely. Yes. I agree with that. Okay, that being said, you bring up a really good topic. Those people who don't have FiOS, those people, you know, Verizon did get hammered. There still needs to be that infrastructure. What are we going to do? Because that capacity is going to get real thin real fast.
They're playing catch up. The reality is they're playing catch up. I agree with the no statement, the in a word no statement. It's absolutely true. They're playing catch up. I mean, long gone are the days when the air interface is the only limiting part of the network.
Right.
Right? That's behind us. Operators understand that, but you can't build that kind of infrastructure overnight. It takes time.
Right, and somebody's got to pay for it.
And somebody's got to pay for it, and it's a lengthy cycle, right? There's a long capital cycle there. So just a word on, you know, why North American operators moved earlier. It really was, if you look at who moved and why they moved, it was really the 3G PP2 guys, the CDMA and EVDO guys who moved early. And the reason they moved early was they had to compete with HSPA, HSPA Plus, and they had no obvious way to do that, right, without going to LTE soon and fast and hard. And so that was, I think, the right decision, and, you know, everyone else had to compete with that decision. But that doesn't mean the network was ready. And they're going to be playing catch up on the network for a long time.
It's always great when when you've got your device, whether it be your tablet, your laptop, your handset, and you grab onto an area where all of a sudden you're getting 35 megabits download per second, and then you walk 3 blocks further and you see an E come up on your phone, and you're like, I'm on an edge network. Does that even still exist, right? But you're like, so the infrastructure is limiting, right? And is it a dog and pony show?
So often what happens in the situation you just described, I'm trying to think where that happened to me on the trip here. It was either on the plane, or I think it was on one of those trains in the airport terminal or something, right? And I had the same experience. Does E even exist today?
Right, absolutely.
And the reason that happens is now that is RAN. You know, that is building penetration. It really is getting signal where customers need it. And
isn't it just easier to go to Wi-Fi offload?
Yes, if it exists.
Okay.
Yeah, and absolutely, and that's one of the many ways to solve that capacity, that coverage problem. It's not always automatic, right? I wish it was. I wish it was easier. An easier way to offload that doesn't require my manual intervention would be fantastic, right? But Wi-Fi offload, or for that matter, LTE offload, small cell offload, is a really important topic because the network is getting busy. There's a ton of people like my daughter who are streaming YouTube 24 hours a day on their phones.
Right.
Right?
Yes.
And how you serve that capacity and where it's really needed is important, because the operators want to put in capacity where it's needed. Like at this convention center, for example, an obvious choice, right? So an understanding of where the traffic resides and why you need to add more makes the economic decision that much easier about where to put it. Right? So we tell people, TrueCall tells people where offload is necessary.
What is 3M's perspective on the type of infrastructure that you want to see pushed out at a faster pace?
Well, so certainly in support of what Warren's saying, we see or openly acknowledge the 10-to-1 mapping of small cells to macros.
Okay.
And I think that as a general figure of merit's pretty accurate. That's not going to be true, of course, in areas that don't have high density, population densities. And already you're seeing moves like Verizon saying, for, say, rural customers where we just can't reach them with a DSL, we just can't reach them with a FiOS line, we're gonna support it with LTE, right?
Right.
So already you're seeing a convergence right there away from the wireline more towards a focus on the wireless side until you get to such a point where the data demand becomes significant enough.
And the
that
cost is relevant to the input of infrastructure.
Absolutely, absolutely, and the take rate and so forth. But in this evolving ecosystem, I think what we see is the desperate need to have fast, economical, and inconspicuous, now that's the key, methods of getting the backhaul and the power to the small cell.
Okay.
Yep. And how do you conceal that? Because, I mean, think about it. You go down to the French Quarter.
Yep.
Now, you go bolt some silver box up there on one of those wrought iron streetlights.
It's not going to look as pretty as the,
nobody's going to like it.
The French quarter posters, you know, make it look. I agree.
Imagine taking one of those nice historic poles and putting, right? How are you going to make that happen? Power, backhaul, and then managing how that fits in the macro network, because there's a whole interference issue. Right? It's not just about putting up a transmitter. How that works within the larger, broader network is a really big challenge.
You can punch them in there at 700 megahertz and try to operate that.
That's the problem.
Right.
That kind of reach. Now, as an operator, now you know, how do you mix your frequency plans, right? Maybe you're a lot better off at a higher frequency when you get in those densities.
Sure.
Okay.
You know, so you got to have multiple bands, and it starts making the devices challenging.
Right.
And,
Not to mention
it gives us a problem to solve.
Yeah.
Which we love problems to solve, right?
Well, it's good for you guys. You're selling more stuff. That's great. Excellent. No problem. Here you go. But there's a management issue on the network side as well, right? Somebody actually has to physically monitor it, right? They've got to, you know, if there's an issue, they've got to go service it.
But I mean, technology keeps moving. So now with self-organizing networks, that whole science. So theoretically, you take what we call a sticky cell, stick it on the side of a building, camouflage it somehow, and when you boot that thing up, it's quiet, it listens, it knows what its RF environment is. If there's a macro there, there's not one here, it's covering this density, and it tries to adjust and triangulate its beam steering so that it fits into that ecosystem, right? Because what they're trying to avoid is constant soft handoffs. In other words, you walk by this cell, and for like 30 meters, you're in the small cell province, but mostly you're in the macro cell. You don't want to be going ping-ponging back and forth.
Well, I mean, the end user doesn't want to have packet loss at all, but, you know, if it's good for the network, then so be it, right?
Well, yeah, it's all about the quality of service.
It's all about the quality of service. You know, fortunately, the Simon Saunders, Andy Germano, the guys over at the Small Cell Forum have done a fantastic job over the last, let's say, you know, 10 years building up to getting the small cells into place, and a phenomenal job in a lot of breakthrough in different types of you know, technologies that are now a good part of the ecosystem, right?
They really are. My takeaway from Mobile World Congress is it could have been called the Small Cell Congress.
Yeah, it could have been, right?
And coming here to New Orleans, it feels very similar to me. I mean, it really does. And the reason it does is because they solve the real issues that operators see today on the network. Okay, and all those issues around how to install, so what type of small cell, how to install it, how to manage it within the network, how to power it and backhaul it.
Right.
There's a tremendous amount of new technology in that area that is being introduced now, and again, these early days, a lot of learning going on, but I think it's real, and I think there's going to be many hundreds of thousands deployed in the next, you know, just in America alone in the next 5 years.
Final wrap-up question for you, gentlemen, and I love to ask this one, especially from your area of the ecosystem. If you had to give the ecosystem a grade letter, what would it be and why, Stephen?
So right now, the ecosystem, I think, is probably at about a C+.
A C+.
About a C+. I mean, they're there. We're leaders. I acknowledge that, but I think that they're scrambling, right? So you have tower hands who are used to working with hardline coax. You have installation companies that are used to doing those types of builds. Then you go in and you say, hey, now you're dealing with fiber. Now you're dealing with this electronics up there. Their labor forces are not quite geared to this. It's like their radio access node guys are not trained to climb the tower. It's, you know, they're trying to adjust to it. What's the proper standards? There are none, really. So
we didn't even get to talk about policy and standards.
What are the standards for bringing up a clean cell site?
Okay.
All of this. But you know, I have to give them an A for effort.
Okay.
You know, but I think it's about a C+.
Omar.
I'm agree with Steve. This is an industry that is in transition. There are still lots of things to be learned, how to deploy, and many of the key players in the industry are making decisions based on what they are learning. So I would say a C+ as well.
Warren.
I'm optimistic. I think it's a B. And I'll tell you why. I mean, virtually everyone has a handset, right? Penetration rates are essentially 100%. Cost has come down substantially, right? So almost everyone can afford a handset now. The data experience is getting better every day. And I get better data experience on my LTE device than I do with my cable modem at home, okay? So I think there's a long way to go, but if you look at the applications, you look at the devices, you look at the cost, I think that, you know, the industry is in pretty darn good shape. I mean, we've done a lot of really good stuff over the last 5 years. There's room for improvement. We could be more efficient with spectrum. You know, the policy topic is this whole separate topic, but I think overall, if you look at the average user experience, it's probably reasonable. Could be better, but not too bad overall.
Mark?
I think probably a C+ is all right. I think, you know, most of us in the industry always want to see things move a lot faster.
Clearly, I would want Warren as a professor, but that's just me.
So, but I think that, you know, one thing that seems to be a little frustrating is you still see people trying to solve a lot of 4G problems with 3G solutions.
Nicely put.
So, you know, and still throwing a lot of investment into 3G, and you know, and at some point, you know, you can look forward and say, well, that has to be undone.
Very nicely put.
The question is when.
When?
So why are we doing it if we know it has to be undone? Okay.
That is a very smart point.
And so that's why I would leave it in the C category.
Very nice.
It's kind of hard to pull up above that.
Gentlemen, thank you very much for taking the opportunity to speak with us on our show here today at the final wrap-up of CTIA. I can't wait to do it again. Maybe next year, maybe in the fall. We'll have to do another professor's panel.
Thanks, Tony. Nice to see you.
Thank you.
All of you out there, don't forget to tweet in your questions, follow us on Facebook, email in your questions. If you have any questions for these gentlemen, don't hesitate to email them into ctia@bnettv.com. We will forward them to the appropriate folks. We have another live show, final wrap-up, live from the floor here at CTIA Wireless 2012 at 1 o'clock. I'm Tony Sklar with BNet TV.